Alright, good evening class. This is chemistry with Shemohai, and I'll be teaching you kinetic theory of gases. The last time I did chemistry, I talked on chemical bond, right? I explained chemical bond for you. So today we'll go on kinetic theory of gases. I don't want to waste too much time, so I'll just go straight to Boyle's law. Alright, let's start. Boyle's law. Boyle's law. Now, what is Boyle's law? Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. I repeat, he said the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. Alright, now, mathematically, Boyle's law is giving us what? Listen to that definition. With the definition, you will understand something. It said the volume of a given mass of gas is inversely proportional to its pressure. So the volume of a given mass of gas, V, is inversely proportional to what? P. Are you getting something now? There is something you got from me. He said the volume of a given mass of gas is inversely proportional. Now, volume is inversely proportional to P, provided our temperature remains constant. So without wasting much of your time, then if you want to do any solving in Boyle's law, now for calculations, when you want to calculate different questions in Boyle's law, here is your formula. The formula for calculating questions is what? P1 V1 equals to what? P2 V2. So the formula for calculating in Boyle's law is what? P1 V1 equals to P2 V2. Volume is inversely proportional to pressure. Can we continue? Alright, now let's go to graphical expression of Boyle's law. Now in graphical expression of Boyle's law, I'll draw there are three graphical expressions of Boyle's law. Let me draw them for you. The first one is this. When you see something like this, let me draw it to I think I not draw it to it's not fine. Sorry. Alright. So this one, I drew something like this. Now your V is going to be here and your P is going to be here. 1. Number 2. We have 1 over P here and we have PV here. Alright. Then the third one is this, where PV will be here. These are the graphical expression of Boyle's law. Remember, I said Boyle's law said that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. And I said volume is inversely proportional to pressure. Now that is giving us as V inversely proportional to 1 over P. And I said if you want to calculate any question in Boyle's law, use P1 V1 equals to P2 V2. Alright. Then I say graphical expression. Why I say V here, P here, PV, 1 over P and PV. Are you getting me here now? Alright. So let's go to calculations. Whenever you see centimeter cube is volume, whenever you see this one here, you know it's pressure. Are you getting me? I don't want to waste much time. Now I say a given quantity of gas occupies a volume of 228. So our V1 is what? It's equals to 228. Alright. Now at a pressure of this 750, so P1 is what? 750. Without wasting much time, I want to try and see if I can see tissue transport today. What will be its volume at atmospheric pressure? So remember, atmospheric pressure is 760. So let's put our P2. Atmospheric pressure is only 760. Yeah. So this is our atmospheric pressure. Everywhere in the world, this is atmospheric pressure. So know this, that this is atmospheric pressure. Then we have what? V2. For V2, V2, they said what will be its volume at atmospheric pressure. So they did not give us V2. And I told you before, the formula for Boyle's law is P1 V1 equals to P2 V2. Alright, P1 V1 equals to P2 V2. Alright. If P1, let me change the marker. Okay. P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. Alright. P1 is what? 750. V1 is what? Times 228 over 228 equals to P2 is what? 760. Then V2. So we have 750 times 228 equals to 760 times V2. So V2 goes here. It will now be 750 times 228 over 760. Let's go. Let me get my calculator and calculate this. So we have 750 times 228 will give us 171 equals to 171,000 over 760. Yeah, so let's get our final answer. Divide, use 760 to divide 171,000. So 171,000 divided by 760 give us 225. Will give us 225. I feel like I keep my marker. Give us 225. Alright, let's go over to Charles' law. Now, Charles' law states that the volume of a given mass of gas is directly proportional to its pressure provided that our temperature remains constant. I'll repeat that. Charles' law states that the volume of a given mass of gas is inversely proportional to its pressure provided that what? Temperature remains constant. Alright, let's go to a graphical expression of Charles' law. Alright, we have three graphical expressions of what? Charles' law. The first one, we have something like this. We have something like this, where V will be here and T, that is temperature in Kelvin, will be here. That is the first one. Then we also have something like this. Here we have V over T, and we have V is directly proportional to T. Then the last, also sorry, is this. Then we have the last one. We have V here, we have T here. We have V here. So these are the graphical expression of Charles' law. V here, T here, V over T, V directly proportional to T, V and T. These are the graphical expression of what? Charles' law. I repeat, I said Charles' law states that the volume of a given mass of gas is directly proportional to its pressure provided that our temperature remains constant. Alright, let's go into one example of Charles' law, then we move to general gas law. Alright, let's enter a question in this, then we'll go to general gas law. I'm trying to rush it. Now, a given mass of gas occupies a volume of 2 dm³ at 300 Kelvin. At what temperature would the volume be doubled? Now, there is something that they said. First, a given mass of gas occupies a volume of 2 dm³. So our V1, there was something I forgot to tell you when I explained Charles' law. I forgot to tell you that the formula for calculating Charles' law is what? It's either you use V1 over T1 equals to V2 over T2, or V1 V2 over T1 equals to T2 over T2. This is how you use V1 over T1 equals to V2 over T2, or you use V1 over V2 equals to T1 over T2. These are the formulas I forgot to tell you before, so take note of this. Alright, now is this formula we are going to use to solve this question. Say a given mass of gas occupies a volume of 2 dm³. Now our V1 is given as 2. V1 is 2. At 300 Kelvin, our T1 is 2. Our T1 is 300. Sorry, our T1 is 300. Right, sorry, it's 300. At what temperature would the volume be doubled? So at a certain point, the volume was doubled, and now they ask us at what temperature. So we are looking for T2. We don't know the temperature yet, but they said the volume was doubled, and to double the volume, double of 2 is what? V2 will be given as what? 2 times 2 equals to 4. Now our V1 is 2, T1 is 300, T2 we are looking for T2, and V2 has already been doubled, and now we have 4. Do you understand? Alright, now let's use this to calculate. Now the formula is what? V1 over T1 equals to V2 over T2, or V1 over V2 equals to T1 over T2. Alright, let's use this first formula. Alright, V1 is what? 2 over T1 is what? 300. Alright, equals to V2 is 4 over what? T2. We are looking for T2, right? Let's cross multiply. Are you getting me now? It should now be 2T2 equals to what? 300. 300 times what? 4. Alright. Divide both sides by 2. 2 cancel 2 over 2. Our T2 will now be what? T2 is equals to 300 times 4 will give us what? 1200 over 2. 1200 divided by 2 will give us 600. Sorry, will give us 600 Kelvin. So now you understand how we got it. First, I brought out all the parameters. 1. Then I used the formula V1 over T1 equals to V2 over T2. Then I arranged everything, cross multiplied, where I had 2 here. So let me write this one where I had 2 here. So divided both sides by the coefficient of T2, cancel with 2. 300 times 4 will give us 1200. Then 1200 divided by 2 is 600. So that is it for Charles' law. Let's enter again general gas law.